Hi guys, welcome back again to Calculus 1 for students in international programs at Kasetsart University. In the previous video, we talked about how to compute derivative using definition, right? And we talked about the differentiability, right? And the interpretation. So in this chapter, we're gonna be talking about the techniques of differentiation. So how to differentiate quickly using some properties. Okay, so let's start. First, the introduction of techniques of differentiation. So first we need to talk about the properties that we can use in order to help us to compute the derivatives quickly. So the first property is that the derivative of constant is always zero. So the derivative of constant is always zero. So the c here is actually a constant. Okay, so for example, the derivative of 3 is 0. The derivative of 7 is, of course, 0. So the proof is pretty simple. So f of x is constant, right? It's c. It's just a constant. So the definition of derivative is limit h approaches 0 of fx plus h minus fx divided by h. But guys, f is always c, right? F box is c as well, right? It doesn't matter what value of box is, but the f is always a constant c. So in this case, we have that it limit h approaches 0 of c minus c divided by h, which is 0. See, because f of anything is just c. Okay. The next property is derivative of x to the n. The derivative of x to the power of n is n x to the power of n minus 1. I won't prove it, okay? So if you are interested in the proof, you can look at the book, and the proof is in the book. So, but if you read the proof and you don't understand the proof, just let me know, okay? I can help you to understand them. But I'm not gonna be focusing on the proof, okay? I'm gonna focus on the application side, okay? So I'm gonna just apply this property, which is the derivative of x to the n is nx to the n minus 1. So basically, you just push n here to the front, and then you subtract n by 1. So let's look at some example. The derivative of x to the fifth is actually 5x to the power of 4. See, you push the exponent to the front, and then you subtract the exponent by 1, which is 4. Make sense? Here, 1 over x is actually derivative of x to the minus 1, right? So if you come across 1 over x, you think of it as x to the power of minus 1. And in that case is minus 1 x to the power of minus 2. And if you want, you can write it as minus 1 divided by x squared. Okay. Here again, the same. Just push minus 1 to the front, and then minus 1 subtracted by minus 1 is minus 2. Make sense? And the next is derivative of x to the power of 1/2, and then you push 1/2 to the front, you get x to the power of minus 1/2. Right? Which is actually, I'll just write it here, 1/2 of 1 square root of x. And that's the answer. Okay, so if you want to go a little bit slower, is half of 1 over x 1/2, which is 2 square root of x. Okay, and that's the answer. Make sense? So we have two properties. The first one is the derivative of constant is 0. The derivative of x to the power of n is nx to the power of n minus 1. So the next property is the derivative of cu when c is again a constant. You can pull c out, can pull the c outside, and then find the derivative of u. For example, here this is 2 d by dx of x squared, which is 2, and then we use the second property, right? X to the power of 2 is 2x to the power of 1, which is 4x. Make sense? Make sense? The next one, the same. I'll just pull minus 3 out, and it will be derivative of x to the power of 5, and that is actually minus 15x to the power of 4. Okay. Okay. The next one is derivative of 5x to the power of minus 1. Okay. But guys, in reality, you might not need to pull it out. You might not need to pull it out because it takes time. You can do it even quicker by just push it down here and multiply it to 5. So what you get is minus 5 x to the power of minus 2. Make sense? Make sense? It's like here. You can just push 5 down here. You get minus 15x to the 4, and it's the same. It's the same answer, just quicker. Okay, so here similarly, if you write it in this way, you can just push minus 1 down. Okay. Sorry. You can push minus 1 down to 5, and then you get minus 5 and x to the power of minus 2. Minus 1, minus 1. And the answer is minus 5 divided by x squared. And that's the answer. Similarly here is d by dx of 2x to the power of 1/2. And that is 2 1/2 x minus 1/2. And that is 1x minus 1/2, which is 1 divided by square root of x. Make sense? And the next one is d by dx of minus 2x minus half, and what you get is minus 2, and you just push this guy down, right? So you get minus 2 minus half, and then x to the power of minus half minus 1, right? Which is it's cancel out, and minus they get plus. Okay, so we have x to the power of minus 3 over 2, which is 1 over x to the power of 3 over 2. And that's it. So easy, isn't it? Okay, so if you have constant times function, you can pull the constant out, and then you find the derivative of function. Okay. The next one if you have two functions, u and v, if you have u and v, the sum of u and v, if you want to find the derivative of the sum of two functions, you can find the derivative of each function. Okay, so the derivative of u plus v is du by dx plus dv by dx. The derivative of u minus v is derivative of u minus derivative of v. Okay. So let's look at some example. Here, as you can see, there are 1, 2, 3, 4 functions, right? It's x cubed plus 3x squared, and that's like the sum of functions, right? So you can, you can do it like this, right? And like that. Okay, but you know that the first one is 3x squared plus 6x minus 2, right? And that's the answer, right? Because the derivative constant is 0. Okay, how about the next one? It will be the first. This is what I would like to do. I would push x up to the to the numerator, right? Put it upstairs, put it up, and if I have these kind of roots, I'll make the exponents to be quotients. Okay, so what I usually do is I'll just do it like this: plus 7x minus 3 minus x squared divided by 3, right? X squared, and then you take the cubic root, which is x squared divided by 3. Make sense? And then you differentiate it, right? You have 1, 2, 3 functions, right? The sum and the minus, you don't care, you just differentiate. Okay, for the sum and the sum and the subtraction, you can just differentiate throughout the equation. So what you have here is 4x minus 21x minus 4 minus 2x minus 1/3. Make sense? Right? Here you push 2 down here, you get 4, right? And 2 here, you subtract it by 1, you get 1, x to the power of 1. Make sense? If you want to do it very slowly, you can pull the 2 out first using property 2, but actually you don't need to do that. It just takes more time. You don't need to do that. And similarly here, I push minus 3 here. Minus 3 times 7, we get minus 21, and minus 3 here becomes minus 4. And similarly here, I push 2/3 down here, okay, and 2/3 minus 1 is 2/3 minus 3/3, which is minus 1/3. Okay, that's why I get this minus 1/3. Okay, and then I have that is 4x minus 21 divided by x to the power of 4 minus 2 divided by 3x to the power of 1/3, which is 4x minus 21 divided by x to the power of 4 minus 2 divided by 3 cubic root of x. Okay, does it make sense? It's actually pretty simple, isn't it? Okay. Okay, so let's look at more example. Okay, here we want to find dy by dx if a, that's the function. So I have here y equals 4 minus right? As I told you, I love to push the thing downstairs, upstairs, okay? Put things in the denominator to the numerator, okay? Okay. And if it has some roots, I'll just make it as the exponent, okay? So the square root is x to the power of 5 divided by 2. Sorry, it's minus because it's downstairs and you push it upstairs. So it must be minus. Okay? And then you differentiate. dy by dx is 0, right? Derivative of 4, which is a constant, is 0. And then you get, what is it? Minus 3 times minus 5 divided by 2. X to the power of minus 5 divided by 2 minus 1. Plus minus 2, right? I'll just put 2 and minus 1. X to the power of minus 2. Okay? Okay? I just push the exponent down and then I subtract it by 1. Okay, subtract it by 1. So what I have here is 15 divided by 2 and x to the power of what? Minus 7 divided by 2, isn't it? Right? It's 7 divided by 2, isn't it? And it's minus 2 x to the power of minus 2. And that is 15 divided by 2. 1 over 7 x to the power of 7 divided by 2 minus 2 over x squared. And if you want, we can write it this way, which is 15 divided by 2, 1 over x to the power of 7, and then you take the square root, minus 2 divided by x squared. And that's the answer. Simple, isn't it? Okay. So the next one. Y is, so here, if you remember the formula, a plus b squared is a squared plus ab, plus 2ab plus b squared. So you look at this as a and this is b. So you have y, which is a squared is 4 plus 2, a is 2, b is square root of x, plus b squared, which is x, divided by square root of x. So your y is actually 4 divided by square root of x plus 4 and square root of x, they got cancelled out, and then plus x divided by square root of x, and that is 4 can I write like this? 4x to the power of 1 minus 1 half plus 4 plus guys x is actually root square root of x times square root of x. Make sense? X is square root of x times square root of x. In that case, you get x. So one of them got cancelled out. Okay, so you get square root of x, which is x to the power of half. Okay, so after that, I differentiate y by x with respect to x. So what I have is 4 minus half x to the power of minus half minus 1 minus half minus 1. Derivative of 4 is 0 because 4 is a constant, right? And derivative of x to the power of 1 half is 1 half x to the power of 1 half minus 1. Okay, so what we have next is -2, right? This guy. This becomes 2 and you have the minus here. So is -2 x to the power of what? -half -1. Guys, -half -1 is -half -2 divided by 2, which is -3 divided by 2. So we have -3 divided by 2. And then plus half of x. Guys, 1/2 -1. You have 1/2, right? 1/2 -1. Here. 1/2 -1. It's actually 1/2 -2 divided by 2, which is 1/2. Sorry, -1/2. Okay. So the answer would be -2 divided by x cubed, and you take square root, plus half and square root of x, and that is the answer. Okay, does it make sense? Okay, the next property is the product rule. So basically, if you have the multiplication of two functions, u and v, so the derivative of uv is u times the derivative of v plus v times the derivative of u. So it's pretty long, right? The rule here. So in order that you can memorize it easily, you can call it as u d of uv is u dv plus v du. Okay, sorry. So it's u dv plus v du. Okay, when I say du and dv, I mean d by dx. Okay, so d of uv is u dv plus v du. So that's easy, isn't it? Okay, to make it a little clearer, because my handwriting is pretty terrible. So it's u dv plus v du. Okay, so let's look at this. For this function, if you don't want to use this property, what you can do is that you can just multiply this this multiplication, right? You multiply 5 by 2x squared, and this and this and that, and then you just differentiate 4 terms, right? You can do that, but it's going to be really messy, right? You need to imagine if you have a really big expression, and it's a multiplication of big expressions. So in that case, it's gonna take you forever. So the easier way is to just use this property. So I'll look at these as u and v. So derivative of u dv, derivative of uv is u dv plus v du, right? When we say this is u and this is v. Okay, so u dv would be 2x squared plus 3x to the power of -1. Dv is just -3, isn't it? Because the derivative of 5, which is a constant, is 0, and the derivative of -3x is -3. Okay, so we have u and dv by dx, u dv plus v, which is 5 minus 3x, and du would be 4x minus 3x to the power of minus 2. Okay, and if you want, you can make it look prettier by, you know, just multiply this guy. Okay, just compute the multiplication of the guy. So we have minus 6 x squared minus 9 x to the power of minus 1. Okay, is 9 to the power of minus 1, right? So the next guy here, this guy. So what I need to do is that I will multiply this first, which is 20x, and then it would be minus 15x to the power of minus 2, right? It's that one. And then I still have this part as well, which is minus 12x squared plus 9x minus 1. Guys, don't forget, x to the power of 1 times x to the power of minus 2 is x to the power of 1 minus 2, which is x to the power of minus 1. Okay, right? For the you know, a to the b times a to the c, the answer is, the base is the same, which is a, and you take the sum of the exponents, right? Okay, so this got cancelled out, right? So I have minus 18x squared plus 20x minus 15 divided by x squared, and that's the answer. Okay, so it's easier when you use this property, right? d of uv is u dv plus v du. Okay, u dv plus v du. Okay, so let's look at this one as well. So here, and as I usually do, I usually push things upstairs, right? Push things upstairs, right? So here, I'll just rewrite it first. So I'll rewrite it as x cubed plus x to the power of minus 3 times 3x squared minus x to the power of minus 1. And then I look at this as u, and this is v. So it's d of uv, right? duv by dx, right? duv with respect to f, with respect to x. So what we have is u, which is this guy. dv is 6x minus 1. Oh, sorry. Plus x to the power of minus 2. Right? Just push the exponents down, right? And then subtract the exponents by 1. Okay? So here is 2. You push it down here, you get 6, and then 2 minus 1 is 1. Here is 1, right? X is x to the power of 1. So you push 1 here, is still minus 1, right? And x to the power of 0 is 1 minus 1, which is 0. X to the power of 0 is just 1. Okay? Here as well, you push minus 1 here, minus becomes plus, and then x to the power of minus 1 minus 1, that x to the power of minus 2. Okay, so we have u dv, and then we take v, which is 3x squared minus x minus 1 over x. du would be what? Would be 3x squared minus 3x to the power of minus 4. Right? Right? So, is x cubed plus 1 over x cubed, 6x minus 1 plus 1 over x squared, plus, oh, we have plus here, sorry, plus 3x squared minus x minus 1 over x. Just remove my camera, and then it's just 3x squared minus 3 divided by x to the power of 4. So, and if you want, you can just stop here. Okay. In the exam, you can stop here as well. I'll give you full mark if you can get, to this point. Okay. Well, let's go to the next property. This one is a quotient, right? It's u divided by v, or u over v. U over v. Okay. So the formula is quite scary. The d of u over v by dx is v du by dx minus u dv by dx divided by v squared. Okay. The way to memorize it is that is low d high minus high d low, low d high minus high d low, over low low, over low low, over low low, which means low squared. Okay, I know it's silly. It's just a silly way of to remember things, but it's if you keep saying it, if you keep saying low d high minus high d low over low low, you're gonna remember it. Okay, you're gonna be able to memorize it. So low d high minus high d low divided by low low, okay, or over low low. It's up to you. Okay, so here low is actually v, right? It's up. This is high, right? This is low. Okay, so high divided by low. So it's low d high minus high d low divided by low low. Okay, low d high minus high d low divided by low low. So here fx is x cubed divided by 1 plus x squared. So they ask us to compute the limit of fx plus a minus fx divided by a when a approaches 0. So guys, it's a, isn't it? So can I change a to h? So it's f of x plus h minus x divided by h when h approaches 0. It's the same thing, right? It's just variable. You can use any variable. You can change it to z, to b, to c, to any variable that you like. But for this form, you are more familiar with the variable h. Okay. So this guy is actually f prime x. So basically, they ask us to find the derivative of f. Okay. So here, this is high and this is low. Okay, this is high and low, right? So if we want to find the derivative of x cubed divided by 1 plus x squared, it's going to be what? Low is 1 plus x squared. Low d high. What is d high? D high is 3x squared. Low d high minus high, which is x cubed. D low is 2x. Right? Low, which is this guy. D high is the derivative of this, which is 3x squared. See? Minus high, which is this guy. D low is the derivative of this. The derivative of 1 is 0. The derivative of x squared is 2x. So low d high minus high d low divided by low low, which is 1 plus x squared. Okay. and I'll just make it look a little better. So I'll multiply, I'll distribute the 3x squared to the left term. So I get 3x squared plus 3x to the power of 4 minus 2x to the power of 4 and 1 plus x squared, which is what is it? It's 3x squared plus x to the power of 4, right, divided by 1 plus x squared, and that is the answer. It's easy, isn't it? So right now we have the product, right, the relative of uv, which is udv plus vdu. Okay, udv plus vdu. Okay, some people they say it front d back plus back d front, but it's up to you. Okay, I just found it. I just found udv plus vdu is easier, but it's up to you guys. But this one is low d high minus high d low divided by low low. Okay, low d high minus high d low divided by low low. Okay, speak with me. Nobody is listening, right? You're studying online, so nobody is listening to you, right? So just say it with me. Low d high minus high d low divided by low low. Okay, again, low d high minus high d low divided by low low. Okay, so the next topic is higher order derivatives. Okay, higher order derivative. So it's basically to find the derivative of derivative. Okay, so that's the definition. We put here is the derivative order n. Okay, so basically if n is 2, we find the derivative twice, and if n is 3, we find the derivative 3 times, and so on. Okay, for example, we can look at this. Fx is 3x to the power of 4 plus 2x cubed minus x squared plus 1. Find this, find f prime, f double prime, and f triple prime. Okay, here guys, this guy is actually dy by dx. This guy is actually dy by dx, and this is the third derivative. Okay, or if you want, you can just write y as fx if you want. Okay, and but I prefer using this notation because it's easier to write, right? Just f prime, we call it f prime. Okay, f prime and f double prime and f triple prime. Okay, I've seen a student he called it f prime and f prime prime and f prime prime prime. It's like prime and f prime, stuff like that. But no, don't call that. Just say f prime, f double prime, and f triple prime. Okay. So first let's find f prime x, which is 12x cubed plus 6x squared minus 2x plus 0. I won't write plus 0. Okay, and that is easy, isn't it? Right. 12x cubed plus 6x squared minus 2x. Okay, I need to make sure it's not wrong. Okay, so f double prime x. So you take the derivative of derivative. So you differentiate this function again. Okay, you differentiate this function again. So what you have is 12 times 3x squared plus 6 times 2x minus 2, which is 36 x squared plus 12x minus 2. Okay. It's easy, isn't it? You just differentiate it again, and you can keep differentiating. Okay. It depends on how many primes you want it to be. Okay, or how many primes you want for the derivatives. Okay. So the second derivative is 36x squared plus 12x and minus 2. And if you want to find the third derivative, basically you differentiate it again. So you get 72x plus 12, and that's done. That's done. Okay. And this is called higher order derivatives. Okay, because here this one we call derivative of order 1, and this is order 2, and this is order 3. So it's first derivative, second derivative, and third derivative. Okay. The next example, let's find the first, second, and third derivative of fx. So f prime x is what? Is minus 6 x to the power of minus 3 plus 4x to the power of minus 2 and plus 1. Isn't it? And the second derivative is 18 x to the power of minus 4 minus 8 x to the power of minus 3 and plus 0, right? And the third derivative is 18 times minus 4. That's not trivial, right? I can't multiply it in my head. So x to the power of minus 5 plus 24 x to the power of minus 4, and 18 times 4 is 72. Okay, so we have minus 72x to the power of minus 5 plus 24x to the power of minus 4, and that's it. Done. Make sense? Okay, let's look at some more example. For example, this guy. Find the fourth derivative of y. Sorry, it's not y to the power of 4, it's just y. Okay, find the fourth derivative of y. So guys, as I told you, what I would love to do is that I would put things upstairs. I know it's a silly word, but to speak it rigorously, to put the thing in the denominator up to the numerator side. Okay, that would be more rigorous. Okay, but to say it simply, we just put things upstairs. Okay, just put things downstairs, upstairs. So what we have here is y equals 3x to the power of minus 4. Okay, so dy by dx is minus 12x to the power of minus 5, and again dy by dx, the second derivative is 12 times 5 is 60 x to the power of minus 6, and similarly the third derivative is minus 360 x to the power of minus 7, and the fourth derivative would be 360 times minus 7 x to the power of minus 8, right? But this guy it would be 0. 7 times 6 42 You have 2 here. You have 4 here, right? 7 times 3, that's 21, which is 25. So we have 25. So it's this guy. Okay. Okay. And then you want it asks us to compute the derivative when x equals 1. When x equals 1. So dy, the fourth derivative of y when x equals 1 is 2520, 1 to the power of minus 8, which is 2520, because this guy is just 1, isn't it? Right? It's 1 divided by 1 to the power of 8, right? But 1 to the power of 8 is just 1, so you know that guy is just 1. So the fourth derivative of y with respect to x, when x equals 1 is 2520. Okay. Okay. The next topic, and this is a confusing one. This is a confusing topic. Okay, which is called chain rule. Okay, it's chain rule. Actually, here, the chain rule, you did it in high school already, but as I told you, it's always a confusing topic. Okay. Okay. First, to look at the chain rules. The chain rule. I'll look at the notation first, the rule first. So dy by dx, is dy by du times du by dx. Okay, so if you want to find dy by dx, it's the same as to find dy by du and then find du by dx. Okay, so instead of computing dy by dx directly, you look at dy by some variable first called u, and then you take the derivative of u by x. Or if you want to look at it this way, you can look at it as a dy by d block and d box by dx, dy by d box and d box by dx. Okay, so let's look at an example. Here, this y. If you want to do it directly, that's pretty easy. You put it as, what is it? Y equals 4x squared plus, look at remember the formula. A plus b squared is a squared plus 2ab plus b squared, right? So if you want to use the apply the formula directly, what you can do is that it's going to be y equals 4x squared. This is a, right? Look at this as a, and this is b. So a squared, which is 4x squared, plus 2, a is 2x, b is 1, plus b squared, which is 1 squared, and this is 4x squared plus 4x plus 1. And so the derivative is 8x plus 4, and that's it, right? So we can do it directly. But how about if I change the question to 2x plus 1 to the power of 200? That is troublesome, right? That's troublesome. It's gonna be a problem, right? Because you don't want to compute the 2x plus 1 to the power of 200, right? And that will be a big problem. It would take you forever. Okay, so what is the chain rule? Look here. First, I'll let u be 2x plus 1. Why? Because, guys, I'll ask you, can you find the derivative of y equal x squared? The answer is yes, it's 2x, isn't it? Right? So how about we just look at this as a big X, or in this case u. Okay. So we will find the derivative of y by u first and then du by dx. Okay, so I'll let u be 2x plus 1. So we have that y is actually just u squared. Okay. So dy by dx is dy by du and du by dx. So dy by du is what? Is d of u squared by du times du is d of 2x plus 1 by dx. Okay. So here is d of u, right, squared by du. You can look at that as a small x or the big X. It's up to you. So du squared by du, that will be 2u, isn't it? It's 2u. And d2x plus 1 by dx is 2x. So the answer would be 4ux, which is 4 times u, which is 2x plus 1 times x. Isn't it? Oops. Sorry, no, it isn't, sorry. This guy, the derivative of this guy is just 2. It's not 2x, right? D of 2x plus 1 is just 2. It's not 2x. So I have only 4u. Okay. So this guy is actually just 8x plus 4. And that's it. Is it hard? It's 8x plus 4. Okay. So look at this example here. Similarly, here we don't know how to differentiate this function, but we do know how to differentiate the square root of x, right? Which is x to the power of 1/2. We do know how to differentiate this function, right? So we let u be x cubed minus 7x plus 1. Right? So y is square root of u, which is u to the power of 1/2. Okay, and then the formula dy by dx is dy by du by dx. It's pretty easy to remember this formula. Why? Because it looks like du cancel out and you get dy by dx. See, the formula is quite easy to remember, because if you have dy and then you have du and then you have du again to cancel out and then you have dx. Okay, first they aren't cancel out. Okay, they aren't cancel out. It doesn't work that way, but it's easier to remember it this way. Okay. So guys, what is dy by du? Dy by du is y is square u to the power of 1/2, right? Du, and that will be 1/2 u to the power of 1/2 minus 1, which is 1/2 u to the power of minus 1/2, which is 1 divided by 2 square root of u. Okay. But u here is 1 divided by 2 square root of x cubed minus 7x plus 1, right? Because u is defined as x cubed minus 7x plus 1. And similarly, du by dx is derivative of, what is it? Of x cubed minus 7x plus 1, which is 3x squared minus 7. Okay, so the answer is dy by du, right? Dy by du, which is this guy. Okay, so we have that is 1 divided by 2 square root of x cubed minus 7x plus 1, and then du by dx is actually this guy. So we have 3x squared minus 7. Is that easy? Okay, and that's the answer. That's the chain rule. Okay, it's a chain rule. Cool. Okay, next example, we're gonna look at, more examples for chain rules, because I found it confusing for many students. Okay, so we're gonna do a bit more examples on these rules. It's unlike other rules which are really straightforward, right? But this rule is a little bit tricky. So let's look at this rule as well. Let's look at this example as well. So we don't know how to differentiate this function, but we know how to differentiate x to the power of minus 3, right? Right? We know that it's minus 3 x to the power of minus 4, right? Right? So we let this guy be u. Use other color. I'll let u be x plus 1 over x, and that is actually what is x plus x to the power of minus 1. As I told you, I love to put things upstairs, okay? I love to put things upstairs. So, y would be u to the power of minus 3. So, what's the formula? The formula is dy by dx is dy by du and du by dx, right? Right? So, dy by du is, what is it? Is minus 3, right? U to the power of minus 4. Okay. It's minus 3 u to the power of minus 4. That's dy by du. Okay. And du by dx is, what is it? You take the derivative of this, right? Right? So du by dx is 1 minus x to the power of minus 2. So here we have that dy by du is actually this guy, isn't it? And du by dx is this guy. So what we have is dy by du, which is minus 3 u to the power of minus 4 times 1 plus x to the power of minus 2. Okay, and that is minus 3 divided by u to the power of 4 times 1 minus 1 divided by x squared. Okay. Just 1 second. There's a glitch. Okay, so as we know that u is defined in this way, so we have that is minus 3 divided by x plus 1 over x to the power of 4 times 1 minus 1 divided by x squared. And if you want, you can make it look prettier, but I won't do that. Okay, so I'll stop here. Okay. Next example is this one. Dy by dx, if y is defined in this way. Okay, dy by dx when y is defined in this way. Okay guys, as I told you, we don't know how to differentiate this function, but we know how to differentiate when this is x right? Because this is going to be 2 divided by what is it? Sorry, I'll let this be x. Okay, I'll let this be x. So it's 2 divided by x to the power of through the 2 divided by 3, right? And that would be 2 of this minus 2 divided by 3, and we can differentiate that function, right? So the idea of chain rule is that you need to look what you can differentiate easily, and then you let that, you look at that and you group this guy as u, right? Group as that guy as u, and then you differentiate. Okay, you apply the chain rule. So here I'll let u be x cubed plus 1. So y is actually 2 divided by the cubic root of u squared, which is 2 divided by u squared divided by 3, which is 2 to the u to the power of minus 2 divided by 3. As I told you, put things upstairs. Okay, put things upstairs. Okay, next. dy by du, oh sorry, dy by dx is dy by du times du by dx. Okay, dy by du times du by dx. So what is dy by du? dy by du would be, you differentiate this guy, right? It will be minus 4 divided by 3 times u to the power of minus 1, right? And that will be minus 4 divided by 3 u to the power of minus 5 divided by 3. Okay, and that is actually 4 divided by 3, 1 over u to the power of 5, and then you take the cubic root. Okay, I push it back down. How about dy by dx? Sorry, du by dx. Du by dx is it's just 3x squared, isn't it? Right? So here dy by du is this guy, and du by dx is just this guy. Okay, so we have that this guy is dy by du, which is 4 divided by 3, 1 over the cubic root of u, which is x cubed plus 1 to the power of 5, and then times 3x squared, and the 3 here got cancelled out, so we have 4x squared divided by the cubic root of x squared, x cubed, sorry, plus 1 to the power of 5, and that's the answer. Is it hard? I hope it's not too hard, okay? Guys, the way to be good at math is to do exercises. Okay, I sent you all exercises, so if you have time, try to practice on those exercises. Okay, if you keep practicing, it's gonna get better and better, and it's gonna become clearer and clearer. Okay. Okay, for this question, again, we want to find the derivative of y by x at x equals 0. So first I'll find the derivative of dy by dx first, and then I will let x be 0 later. Okay, so first, if you look at this function y is already in terms of u, okay, and u is already in terms of x. Okay, so first I'll look at dy by dx, which is dy by du and du by dx. And dy by du is what? What is dy by du? Dy by du is the quotient, right? Here we have high and low, right? We have high and low. So dy by du would be low d high, which is 2, minus high is 2u, d low, which is minus 4, divided by low. Okay, and what's that? Is 2 minus 8u minus plus 8u divided by 1 minus 4u squared, and this cancel out. So what we have is 2 divided by 1 minus 4u squared, and that's dy by du. Okay, so the next one is to find dx by du. Sorry, du by dx, which is d by dx of 2x plus 1 to the power of 4. But again, guys, we don't want to compute this term, right? So we then can apply the chain rule again, right? Because if I let this be the big X, you can differentiate this function, right? So I'll let w be 2x plus 1. So u is 2x plus 1. Sorry, u is actually w to the power of 4. So in one question, you can use chain rule multiple times. Okay, you can use it like 5 times, 4 times, or I don't know, multiple times. Okay, so here what I have here is du by dx is du by dw and dw by dx. Again, it looks like these got cancelled out, right? So you have du by dx. Okay, so du by dw, what is it? What's du by dw? Du by dw is d of, what is u? U is w to the power of 4 by dw, right? And that will be 4w cubed. Okay, and the w by dx would be d of 2x plus 1 by dx, and that is just 2, isn't it? So du by dx is du by dw, which is 4w cubed times 2, which is 8. W is 2x plus 1 cubed. Okay, so it's 8 2x plus 1 cubed. So we have that du by dx is x 2x plus 1 cubed, and the y by du is this guy. So we have got the answer is 2 divided by 1 minus 4. And what is u? We let u be 2x plus 1 to the power of 4, right? And then squared. Right here, this is the I'll use some other color. That's the definition of u, isn't it? Right, and then multiply that by du by dx, which is 8, and 2x plus 1 cubed. Okay, So the answer is 16 2x plus 1 cubed divided by 1 minus 4 2x plus 1 to the power of 4 and then cubed up squared, sorry. Okay, and after that we let x be what? 0. We let x be 0. So if x is 0, we have that, what is it? This guy equals to what? 16 times 1 divided by 1 minus 4 times 1 to the power of 4, which is just 4 squared, and that is 16 times minus 3 squared, which is 16 divided by 9. So I'll just move this guy over here, okay? And then I have that this is just 16 divided by 9. Okay, and that's when we apply chain rule twice. Okay, make sense? And again, this is the last example on chain rule. Here, as you can see, you probably aren't able to differentiate this whole function. So what you can do is that you can differentiate, you know that you can differentiate this guy, which is x squared. So it's 2x, isn't it? So first thing I would do is that I would let u be 3 plus square root of x squared minus 3. Okay, so I have that y is actually u squared. Okay, and then I know that dy by dx is dy by du times du by dx. Okay, and we know that dy by du is 2u, right? The derivative of y with respect to u is 2u, and du by dx is, what is it? Is derivative of u is 3 plus square root of x squared minus 3. But guys, again, we can't differentiate this function. But what we can differentiate is when this guy is just x. It's going to be 3 plus square root of x, right? Which is 3 plus x to the power of 1/2. And the derivative of that would be 1/2 x to the power of minus 1/2. Isn't it? So we can't differentiate this whole function, but we can differentiate it when this guy is a big X. So what we need to do is that we need to use another chain rule. So we let w be x squared minus 3. Then u is 3 plus square root w, which is 3 plus w to the power of 1/2. Okay, and du by dx is du by dw and dw by dx. Again, it looks like they got cancelled out and you got du by dx. Okay, so du by dw, what is it? Du by dw is half of w minus half, right? It's half of w minus half. Okay, so That is du by dw. And then dw by dx would be 2x, isn't it? You differentiate this guy by x. You have 2x, this cancel out. Okay, okay. So du by dx would be du by dw, which is half of 1 over w square root w, right? Right? This guy, I'll do it a little quickly here. This guy is du by dw, right? But here is half of what? Of 1 over w 1/2, right? Right? And that is just this guy, isn't it? Okay, okay. And dw by dx is 2x. So the 2 got cancelled out. So we have x divided by square root, and w is x squared minus 3. So right now we have du by dx, du by dx. So to find dy by dx is dy by du, which is dy by du, where is it? This guy, right? And du by dx, which is this guy. So the answer would be 2u times x divided by square root of x squared minus 3, and that would be 3 plus square root of x squared minus 3 times x divided by square root of x squared minus 3. Okay, okay. And if you want, you can rearrange the term a bit, but I'll just keep it like this. Okay, I'll just stop here. So that will be the answer. Okay, let me summarize. Let me summarize this question. First, we look at y equals this guy, but again, we can't differentiate this guy, right? There are no such properties, right? So what we can do is that we can differentiate it when this guy is the big X, right? So we know that there would be 2 big X to the power of 1, right? The relative of that, big X squared. So we let the big X be u. Okay, so y is u squared, and as you can see, we can differentiate y by u. Okay, so the chain rule says that dy by dx is dy by du times du by dx, and we can differentiate y by u. And to differentiate u by x, u is defined as this, right? So again, we can't differentiate this. We don't know how to. There's no such rule, right? Right? We know only how to differentiate x to the power of n, right? But we don't know how to differentiate square root x to the power of n plus 3. In that case, we don't know, right? Right? So, but we would know if we let this guy be a big X, and that would be 3 plus big X square root, and there will be just 3 plus big X to the power of 1/2, and that is differentiable, right? We know how to differentiate it. Okay, so so we let w be this guy. Okay, so u is just this guy, which is this, and that can be differentiated with respect to w. So du by dx is du by dw by dx, okay, from the chain rule. And then we find du by dw, which is pretty easy to compute, and du by dx, which is even easier. Okay, and then we do substitution, we put it there, and we get the answer. Okay, so guys, that is done for this video. So we talked about the chain rule, right, which is confusing for many students. I believe that when you were in high schools, many of you don't care about chain rule. You just keep using the word side, right, and keep doing that. I can teach you that way as well, but you know, if you look at the Thai version of this video, you're gonna see that I use that approach as well, but you really need to know it in this way as well. They are actually equivalent, okay, but you need to know it by definition as well. You need to be able to use it as well. Okay, that's why I teach you this way. So the key to understand the chain rule and to be able to apply it to questions precisely, okay, to apply it to question without any mistakes, is, again, as I emphasize, is to do exercises. Okay, so after this video, guys, just look at exercises for chain rules, and then just keep practicing them. You know, just do like 2, 3, 4 of them, and if you get them right without any, you know, any errors, that would be great. Okay, you can move forward to the next topic. But you know, if you are struggling, you don't know how to do them, you keep practicing. If you have any questions, just ask me, okay? But just keep practicing, guys, okay? It takes time. It takes time. It won't be that easy, okay? In the exam, there are definitely questions on chain rules, and there are gonna be many of them, okay? So and the chain rule is going to be used in the later chapters as well, okay? So we need them. We need the chain rules in later sections and later chapters. So if you don't know them, just practice them. Otherwise, you're gonna be in trouble for the next chapters as well. Okay, so today, just bye bye and just take care.